Welcome to part 2 of the Rocket Lasso Slicer plugin training. In this video, we're going to be talking about the Matrix mode and the Modify tab. Here I've got a text object fed into a volume builder, into a volume mesher, just giving us a nice blobby text overall. And then I've also got a landscape that we'll be using a little bit later on. Now, to begin with, let's create a slicer from your extensions or plugin dropdown, or I've got it in the interface. Dragging it to the bottom, I would like to remote link into an object. That object will be the volume mesher for the text. Then how about pivoting from the bottom? And that is the total space there. I'm going to be very specific with where I place this because you'll see in a moment how that's going to work out for us. And let's even create a few extra cuts. Okay, so you can see how that has chopped everything up. We've got these nice cuts going. Let's hide our geometry and then click the Create Matrix button. What's going to happen is it creates a brand new matrix object. It turns on matrix mode. It puts that matrix object into the link field, and the matrix object has taken on the properties that the slicer already had. It starts at the same place, it ends at the same place, and it has the same number of cuts. So all that gets pre-set up for you just by clicking that Create button. Now that this has happened, you can see that these slices are grayed out as well as rate and all of these spacing options because that's all been taken over by this matrix object. So by using a matrix, it's unlocked some additional options. We can change the number of cuts, but this unlocks the ability to do something like use a random effector. So let's create a random effector, and you see those are now randomly placed, and we get this different random spacing. That different random spacing, the only thing that Slicer cares about is the Y position because that's the orientation we're on. The rotation doesn't change even if we randomly rotated those. That has no effect on, let me put in a number there, you see it has no effect on the slicer because all it cares about is the Y position of those matrix objects. So now that that has happened, we could animate these somehow. Let's say this gets set to a random noise and we index that, hit play, and as those animate around, the slicer will automatically take those properties on as well. This is unlocking all of the power of the matrix and effectors and fields and allowing those to feed into the slicer, which just, of course, increases the amount of power by a lot. Now, there's even more we can do here. Let's create a brand new spline. So from this front view, I will draw a brand new spline. So I'll say spline pen tool, just draw a line, good enough. It's not perfectly straight, but that'll be good enough for what we're doing. I would like this matrix to clone onto an object. That object will be this spline. So now let's turn off random just for a little bit. In fact, we'll delete that. So now we have a series of matrices cloned onto a spline. And that, by being on a spline, unlocks some additional options. First of all, we could change the count again if we want to. But now we can change the rate and hit play. And now you can see that we have an animated matrix, which is now corresponding to an animated slicer. And we could change the rate variation, and those could each be traveling at different speeds, unlocking even more functionality that way, which is pretty cool. And then, even more fun is let's add on some random colors onto this thing. So let's change the matrix color to maybe a blank white color, and then create a brand new random effector. And we don't need any random position, but I would like some random effector colors. You see we get all these crazy colors. In fact, you get better colors if you go to the effector tab and take the minimum and drag it up to 0, and now you can get any random color from black to white. So, having done that, moving back into our slicer, this is kind of jumping ahead a little bit for what Slicer can do. But if we go into the spline tab, we can explode these individual layers. So segments, I'm going to say, don't return as one object, return as a bunch of different objects. And then those different objects can now get colorized, and I can say colorize from matrix. So if I deselect, you'll see that every cut is based on the color of the individual matrix node. So hitting play, you see those traveling around, taking on the color, just automatically working. Create as many cuts there as we want by increasing our count. Create a ton of cuts, and you just see it translating directly over. Add more random speed if we want to, speed those up, go slower. Lots of options by unlocking the power of the matrix inside of Slicer. Pause that, rewind. Let's just simplify this. We don't need the matrix, don't need random, don't need the spline. And we'll just go back to, and don't explode the layers. Pretty much just starting as if it's a brand new one. And don't be in matrix mode. Okay, we're back to normal, back to our regular cuts. So that is using a matrix with the slicer. Moving into the Modify tab, we can see we have extra options to play around with. Not too many, it shouldn't take too long to explain these. Now the first one is our point order, and I would like to show this in a little bit clearer way. So why don't we show our original object? I will expand these by 1 just so they poke out from the object a bit. And let's even change the display color to just be white, so even when I'm deselected we can see those lines very clearly. And then, creating from scratch a brand new matrix object, I will set this to clone onto an object. The object will be the slicer, and I want this to create exactly 1 per line. Now they're actually all hiding back here, but I'm just doing this to illustrate this is where the first point of any given segment here is existing. So that's the first point, that's the first point, that's the first point. So having done all that, we can now start talking about, in the Modify tab, these set first point. Now, as these slices are cut, we don't know where the first point should be. It could be anywhere. So out of the box, we don't know where it's going to cut. So if you set it to none, it's just wherever the calculation happens to put the first cut. So that's fine, but it's not always going to be something that's coherent. So instead, you can turn on the default, which is Z plus X plus. What that's going to do is find the Z most point and make that the first point. If there's a tie, it'll then pick the X most point after that. And if there's another tie, it'll do the Y most point. But you see that now gives us a consistent output that we can control, and it's going to unlock very specific things. This is really nitty gritty, and 99.9% of the time you won't have to worry about this, but every once in a while you will. And probably in the quick start, we'll get an example where this is super practical. But right now, just for talking about the settings, we can also change this to something like random. And now it's randomly picking a point on each of those splines to be the first point of that spline. And then lastly, we can say closest to, and now it's going to go the closest possible point on any given spline to, in this case, 0, 0, 0. Let's create a null. So let's say create null, and now there's a null right there. If I grab that null and move it, all of these are going to attempt to get as close as they possibly can to wherever that null is starting. So this might be important if you want a starting point. Let's say we move this way over here. So all of those are moving to be as close to that as possible. So if we had a bunch of straight lines, it would be like, oh, start here and then travel to the left. Very specific, but it can create some cool things. So I want to explain that thoroughly. That can go back to the default of Z plus, X plus, and we don't need the start point anymore. Moving on, we want to check out the redundant points. So we've still got that matrix hanging around. Let's have it do more work for us. I'm going to say matrix, I would like you to clone onto every single point. So now every single point on this object is getting a matrix object. It's a little big, so let's set that to 0.2, 0.2, 0.2, and there we go. Oop, 0.2. And then you can see we get a little matrix per cut. And you can see that there's exactly a matrix on the side of every edge that we would have intersected to create that cut. Now, the setting I would like to talk about is remove redundant points. So you can already see it here. I'll turn it off, and you'll see that every single edge is being cut. But over here, this is a very straight line overall. So if I turn on remove redundant points, Slicer is detecting that that is a perfectly straight line, and thus those extra cuts don't matter. Those aren't adding anything. If you were creating geometry from this, that would just be slowing you down. So this is removing those redundant points. You'd see this most blatantly if we do something like create a cube and set this to, I don't know, let's just do 20 by 20 by 20. And if we say, hey, cut that cube, so in the slicer, let's also add in this cube. You can now see that in spite of all of these different edges, it's only creating a point on the corners. If we turn off remove redundant points, then we will now get a point on the spline in between every single one of those. And just for clarity, this is if you make this editable and then you go to point mode, these points are being created. So that's what we're talking about. Okay, bringing that back in, we don't need the cube anymore. And the slicer is doing a good job. Turn the matrix back on again, because I would like to talk about the next setting, which is actually really important and pretty powerful, which is non-planar points. And for this, we need the landscape. So let's turn that off, hide it, add in the landscape, turn on the landscape, and yeah, excellent. So now you can see, let's actually turn off the matrix for a moment. So here we've got this crazy landscape going on. To show this properly, let's take that expand and get rid of it. So no expand. Okay, so this is perfectly on the edge. And now, being perfectly on the edge, you'll see that a bunch of our lines are disappearing. Why is that line disappearing? It's there, it's connected on the inside, you can see it there, but why is it inside the object and not directly on the surface? Well, that's because a lot of models that you're working with are not going to be planar, meaning the individual polygons are not necessarily perfectly flat polygons. So let's find like a rough one, like right here. You see we've got this polygon. If I go and spin the camera in a really extreme way, you can see that this one polygon definitely isn't flat. It goes up, down, over, up, down, over. So it's almost like it's two triangles, and those have additional dimension to them. So those are not being currently acknowledged by the slicer, but they can be just by turning on non-planar points. Now, essentially, we're triangulating the mesh so you can get that perfectly on the edge all the way around. Now, we're not actually triangulating. We're doing math to make sure that we do it properly so it doesn't take the extra speed hit. But along those lines, that can be important, but keep in mind that oftentimes you won't need that to be turned on. You don't need those. And it does create a lot of extra points. So to show you, let's turn that off and create the matrix again so you can see where all these matrix points are. But on an object like this, by turning on non-planar points, it's almost going to double the point count. You see how many more points there are because it's pretty much like everything's getting triangulated. Only if it needs to, but a lot of these need to. Keep in mind that those points will be taken into account if you were to move into the smooth parameter. So if we say, yeah, add some smoothing layers on there, you can see how even all of them begin to get as they average out based on where their neighbors are. So yeah, a nice combination of settings there. Now, next up is remove tiny, and this one's pretty straightforward. We have a series of different points here that are getting up pretty high. Maybe you don't want the very small ones to show up. So if I start increasing this threshold, as I increase, you'll see that that tiny one disappeared because it was really small. I could keep on increasing this threshold more and more and more. You're going to see each little segment. It's going to take a while to get to the next one. But there we go. You see that one disappeared. And if I keep going, this one is the next smallest. It will remove that one as well. Now, most of the time, that's not going to matter too much for you. But if we put that back to the default, this is actually pretty important when it comes to smoothing. Under Slicer, I'm going to hide our landscape. And if we start smoothing something, by definition, these points are getting closer together as they average out. So you see something like on the top right here. I'll turn the matrix off so we can see the line better. You'll see this top one is starting to shrink as we iterate and make it smaller and smaller and smaller. So eventually, if that gets really small, you want it to disappear because you don't want all these infinitely tiny points that are made up of dozens of points eating up the space, creating geometry you don't want to. So anyway, that's the point of the threshold. By increasing this threshold to a different number, we can make it large enough that that will now disappear. That's the point of that, but it can actually be pretty helpful in some very artistic scenarios, not just a technical one. So that's remove tiny, put that back to default. And lastly, we have polygon selection. This one's pretty straightforward, but again, can be pretty powerful. This landscape is pretty handy. Let's make it visible, make it editable, and make a selection of some sort. I'm just going to paint in the selection, and that's perfectly fine. We'll do a little bit more right there. Okay. Select, store selection, or set selection in older versions of Cinema. And then inside of our slicer, say, hey, limit to that polygon selection. We will now see that only those edges are being cut. But you will now see that we get these crisscrossing lines on some of them. And that is because slicer by default is set to closed. It's a closed spline. So in this case, we need this to be an open spline. So actually, if we go to slicer, you will see that it's yelling at it saying like, oh, open edges have been detected. So I'm going to say, yes, I would actually like to swap to an open spline. That's the same as going into the spline tab and saying, this isn't closed, it's open. So that's what we've done. Those are now open lines, and we can now see those nice and clearly. I will have those pop away from the surface a little bit again so we can see them clearly. Okay, excellent. So you can see that that is based on our selection. But this unlocks the ability to use fields. And of course, anytime you can feed in Mograph objects, everything gets more interesting. So in that selection tag, I can say, yes, use fields. Don't worry about that previous selection. I would like a random field. This random field will make pretty large. And there we go. As we go larger, this is constantly updating the selection tag. So if I double click, that is what this noise is feeding into it. And now only those selections are being cut, meaning our slicer is nice and kind of randomized along this landscape. So if we hide the landscape, grab that random field and give it some animation speed, we can now hit play, and slicer will be animated along based on where that noise happens to be. You can imagine a lot of different combinations where this could start to get pretty interesting. But yeah, just creating this is pretty neat, and all that just by doing a selection tag inside of it, inside of your modify tab. So that will wrap this video up. I'll see you in part 3 when we are going to be talking about the very exciting geometry tab.